Welcome back. Today we're talking about multiplying fractions. Imagine multiplying fraction like eating a pie over multiple days. Well, frankly, if you're eating one pie over one day, that's a really sad existence, and you're probably going to have a stomachache. Now pretend you went out and bought a delicious apple pie. Day one, you eat 1/3 of that pie. You cut the pie into 3 equal pieces. You eat one of those pieces. What fraction is left? Well, there were 3 pieces. I ate 1. There are 2 left. That's 2/3. The next day, you're going to eat half of your leftovers. So you cut the leftovers right down the center. So there's 2 equal pieces. Right now, of the original pie, you're eating 1/2 of 1/3 or of 2/3 of a pie. Now, if you know multiplication of fractions, that's a part of a part. That's 1 or 2/3 times 1/2. If not, see if you can visually on your own figure out what fraction of that pie is left. Now, to multiply fractions, a lot of students immediately say cross multiply. Cross multiplication is reserved exclusively for proportions. That's only when you have a fraction or a ratio equal to another fraction or ratio. We're going to see that in a unit or two. Now, in this case, you're just going to multiply your numerators straight across. This will become your new numerator. 8 times 6 is 48. Multiply the denominators straight across. This becomes your new denominator. 9 times 12 is 108. The last step in every single fraction problem, whether you're adding, subtracting, multiplying, dividing, solving, anything, is to simplify. In this case, I'm going to do single mountain method. Single mountain's great when one of the values is big and one of the values is not so big. So in this case, I'm going to find the factors of 48. Your calculator is a good tool for using the double or single mountain method. Always start with 1 and the value you're finding the factors for, and then climb the mountain. 1, 2, 3, 4, in order. Check each factor. If you plug it into your calculator and it divides to a whole number, it's a factor. For example, 48 divided by 2 gives me 24. So 2 and 24 are both factors. 48 divided by 3 gives me 16. 3 and 16 are both factors. 48 divided by 4 is 12. 48 divided by 5, decimal. 48 divided by 6 gives me 8. 48 divided by 7, decimal. 48 divided by 8, I'm on the other side of the mountain. That's the best part about the single or double mountain method. It tells you exactly when to stop. It tells you when you have all your factors and when you have them in order, which makes it a lot easier to select the greatest factor in that list. Now, with the single mountain, I'm going to check by division. 108 divided by 48, decimal. 108 divided by 24, decimal. 108 divided by 16, decimal. 108 divided by 12 gives me a whole number. That's the first factor from 48 that is common to 108. So my greatest common factor is 12. Divide top by 12, bottom by 12. I end up with 4/9. Circle your answer. Since you're showing so much work, we want to be able to find where your answer is. Let's try another one together. Multiply your numerators together. 6 times 2 is 12. 5 times 8 is 40. So you have your new numerator, you have your new denominator. Simplify. I'm going to do double mountain since my numbers aren't that huge. Factors of 12. 1 times 12 is 12. Again, check with your calculator here. 12 divided by 2, whole number. It gives me 6. 12 divided by 3, whole number. Gives me 4. 12 divided by 4, I'm already on the other side of the mountain. I'm done. For 40, always start with 1 in the number, then climb the mountain. 1, 2, 3, etc. 40 divided by 2 gives me a whole number. 40 divided by 3, decimal. So 3 is not a factor. 40 divided by 4 is 10. 40 divided by 5 is 8. 40 divided by 6, decimal. Divided by 7, decimal. Divided by 8, I'm on the other side of the mountain. Again, a calculator is a great tool for the single or double mountain method. Otherwise, you can use your divisibility rules. The biggest number in both of those lists is 4. So I'm going to divide top and bottom by 4. I end up with 3/10. On your own, give 2/5 times 6/3 a try. These are some variations. They're not necessarily different versions of the problems. They're not necessarily new types of multiplication problems. They're just what happens if. So what happens if you have negatives? If the whole fraction is negative, the negative sign is outside in front, put the negative in the numerator. If the negative's already in the numerator or the denominator, it's easy. It's fine because we're breaking it down into numerators and denominators. You don't want a negative out by itself. So I'm going to put the negatives up top. Negative 4 times negative 6. Follow my negative multiplication rules. Same sign gives me a positive value. Negative 4 times negative 6 is positive 24. 7 times 3 is 21. Now I'm going to simplify. I'm going to do single mountain. 1 and 21. 21 divided by 2, decimal. 21 divided by 3, decimal. Oh, sorry, whole number, 7. 21 divided by 4, decimal. 5, decimal. 6, decimal. 7 is our next whole number that works. So I'm done. I'm on the other side of the mountain. Now, I know my factors. 21 is not going to divide out of 24. 24 will not divide evenly using 7. 3 is my greatest common factor. Divide top and bottom by 3. That gives me 8 sevenths. Now, I notice this is an improper fraction. Remember, if it's heavier on top, it's improper. So, I need to take 8 divided by 7. I get 1 as a whole number. I can then take whatever's left for my remainder. That's my new numerator. My denominator stays the same. On your own, try negative 9/8 times negative 2/9. Now, what if it's a whole number that you're multiplying by? Write the whole number over 1. Any whole number can be written as a fraction with 1 as a denominator. It's being broken into one part. So in this case, 3 becomes 3 over 1, giving me a numerator and a denominator to multiply. 3 times 4 is 12. 1 times 8 is 8. I'm going to do double mountain here. 1 times 8 is 8. 2 times 4 is 8. 3 does not work. 3 is not a factor of 8, so I'm going to move on to 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. I'm on the other side of the mountain, so I am done. The biggest number in both lists is 4. Divide top and bottom. Again, this is an improper fraction. I know that 2 goes into 3 one time with 1 left over, giving me a numerator of 1 and a whole number of 1. Always double check the fraction portion of any mixed number to see if you need to simplify. In this case, 1/2 I know is in simplest form, but you may have to do a second set of simplifying. Mixed numbers. What if you are multiplying mixed numbers? Always turn them into improper fractions. Mixed numbers are great for communicating values. 1.5 cups of sugar. 2.5 pounds of chicken. Improper fractions are great for calculating values. And that's what we're trying to do. So turn them into improper fractions first. So 5 times 3 is 15, plus 2 is 17. 1 times 3 is 3, plus 1 is 4. The denominators stay the same. Then you just follow the same rules. So it's a little change, but the same exact rules. 17 times 4, 68. 5 times 3, 15. Now I'm going to do single mountain in this case. Factors of 15, 1 and 15. 15 divided by 2, decimal. 15 divided by 3 gives me 5. 15 divided by 4, decimal. 5 is the next number I'm going to check. It's on the other side of the mountain, so I'm done. Single mountain means I need to double check everything. 68 divided by 15 gives me a decimal. 68 divided by 5, decimal. 68 divided by 3, decimal. 68 divided by 1 is the only factor that works, which by definition of the simplified form, we're done. However, it's an improper fraction, so I'm going to divide 68 by 15. I get a decimal. I get 4.53. The 4 is going to be my whole number, but to find the rest, I need to figure out what my remainder would be. A little shortcut, instead of doing long division. I know that I'm taking away 4 sets of 15 in this case. So, I set up an order of operations problem. Take my numerator minus how many sets of my denominator, or whole sets of my denominator, I can divide out evenly. And that will give you your new denominator in the improper fraction portion of the mixed number. So I'm left with 4, because it's 4.53, and I get 8 over 53. Or sorry, 8 over 15. On your own, give the next problem a try. Thanks for stopping by, and I will see you in class.